Thank you for having me here. It's a pleasure presenting our implementation of DATEX II in Greek tollway operator Egnatia Odos SA. I am representing our company, which developed the implementation on behalf of our client, the Egnatia Odos SA. First, and also I'm representing Egnatia Odos SA today. So I would like to begin with a couple of words for the operator, and we will continue by explaining what we implemented and what do I mean by dynamic implementation. So, give me a second. Okay. Egnatia Odos tollway, its main axis is over 600 kilometers of motorway that crosses northern Greece. It composes of vertical axis as well, approximately 250 kilometers, connecting Greece with neighboring countries. Its traffic management centers got upgraded during this project, and in detail, there was an upgrade in 5 regional traffic control centers, and we also developed a single access point for data collection and dissemination, which are related to the ITS Directive 2010/40/EC. Furthermore, during this project, we developed a bridge with a national access point in order to forward the data from a single access point with lays inside Egnatia Odos infrastructure and to the national access point. So concluding this project, national access point retrieves data from Egnatia Odos SA in DATEX format, DATEX II format, and it provides the data publicly to everyone who is interested in getting this data. Now, Egnatia single access point is a server inside the operator infrastructure where multiple data get organized and collected in a single location. This data consists of weather condition data from weather stations that are located on the network of the road of the operator, video from web cameras that are also located in the network of the road of the operator, traffic events and data that are retrieved from SCADA systems along the network of the roadway, and lastly, VMS messages from the network as well. All of these are getting gathered in a single location, and we elaborate the data in a way so DATEX II can pass them through to the national access point. The publications that we used, that we implemented for our client are the following. Elaborated data publication and predefined locations publication are being used to gather traffic flow data, to serve traffic flow data from loops data, I mean the SCADA system with the conductive loops on the road, and VCA data. This describes the vehicle flow as it is perceived from the cameras on the motorway. To continue, we also implemented measurement data publication and measurement site table publication to accommodate weather condition data from operator weather stations. As I mentioned before, we also implemented VMS publication and VMS table publication and situation publication to accommodate and serve VMS text messages and event situation accordingly. Now, I'm going to speak about the dynamic implementation we developed here in this project. The main characteristics of our design and implementation are 3. During the design of this project, we realized that we don't want to provide something to our customer that it's very bound to its design. We wanted to make something dynamic, so the client can parameterize it and change it at will without us have to step in and change the code of the backend or something like that. So at first, we implemented a structure-driven architecture. I will talk about all these 3 points in a couple of minutes. Secondly, we made sure all entities are highly parameterized in the system. And lastly, we took advantage of these 2 points and moved on to providing a modular component system. So let's take a look on each of these points. Structure-driven architecture. So at the point we are getting data from either of the subsystems, either we're talking about weather stations or traffic data from VCA cameras or SCADA systems, we designed our system to not be bound to the data itself. For example, we have a software that connects SCADA systems on the motorway with our server. And this software, as most of you may have experienced, is used to transfer something that is called tag. A tag is a data for describing a specific information. For example, vehicle speed on a specific point of road. We designed the system so that, yes, we get this data, we get this tag information, but it is parsed in a tree directory. And therefore, from this point after, we are accessing this information by referencing this tree directory and not the data itself. This is also what we used in order to receive the input from file data, such as weather stations and some other inputs that come in the form of CSV or other file inputs. This leads to a great flexibility and updatability, since the client has the ability to change the actual data inside the tree structure, and the whole chain will remain intact. For example, we have designed a tree for getting data from a specific type of information, loop vehicle speed, and inside there is a tag named XXX. If the operator would like to replace this tag with another type of information, the tree directory will remain intact. The whole chain of the information will keep on going because we are not referencing this tag on itself. We are referencing the tree directory. For this, in order for this to work out, the operator has only to keep a few rules in mind that describe how the directory tree should be implemented, the name of some folders containing information such as loops or vehicle messages or VMS messages, I'm sorry. And if the operator keeps these rules in mind, he can keep the tree directory intact and the chain of information intact as well. Moving on, sorry?
You have some just 1 or 2 minutes to conclude. Sorry.
Okay, no problem. It's enough. Moving on, we highly parameterized our entities, and for example, I have 5 points here: the location, the weather station sensor that are available, the mapping of the vehicle types that we're getting from SCADA systems to DATEX II vehicle types, and event characteristics such as a situation type, location, and lanes of the situation. All these are being provided to our client via a graphical user interface for him to parameterize. These 2 characteristics leads us to modular components. The client has the ability to edit user-defined DATEX II general information, such as national identifier, country, language, and confidentiality. And also he has the ability to edit user-defined DATEX II specific parameterization, such as weather station, weather sensors availability, event to situation record type mapping, DATEX folds, And of course, as I mentioned before, the user has the ability to switch on, off, or off specific locations and namings. I'm referring to the tree directory here of the system. This ends up in complete control to user and maximum scalability. The user can decide how many sensors of the weather stations will end up in DATEX II information to the NAP. The user can decide what data in schema updates will take place without us having to interfere in the backend. User has complete control, and the system is dynamic, allowing the user to scale from one loop information to 100 loop information on a single publication. I don't want to take any more time from the next speaker, so I would like to thank you very much at this point for your attention. And on behalf of Egnatia DOS SA and Link Technologies SA, if you would like any more information on our dynamic implementation of DATEX II, feel free to contact me in the email you see on your screen right now. Thank you very much.